Greetings everyone. So in today's lesson we are concluding what we get to call differentiation. In that we are going to look at this particular topic that is called what? Stationary points. So this is what we are looking at. Stationary what? Stationary points. This is a subtopic that I want us to look at. So how then do you get to find the stationary points on a curve? No one should say, me, I don't know these parts. This is just a continuation from a topic that is called what? Quadratic equations. You get to involve quadratic equations and even just simple equations and what? And linear equations. And linear what? Linear equations. This is just some simple questions. I give you an equation. I give you a quadratic equation. The build-up concept is coming from these ones. So the prerequisite knowledge that you need to get is understanding these two. How to solve a quadratic equation and how to solve a linear. When I say linear equation, these are equations. X plus 2 is equal to 4. Are you able to solve these equations? So these are called linear equations because there the highest power is 1. So they are called linear equations. So are you able to solve this type of equations? You know, here you just say x is equal to what? 4. This one is positive. When it goes this side, it becomes negative. So you are able to agree with me that x is equal to what? X is equal to 2. This is just as simple as that. So this is where the foundation is, and this is where the whole topic is coming from. Those of you that recently joined and you were not there when I started calculus, lesson 1, lesson 2, don't even worry about anything. When we end the today we finish differentiation. So tomorrow I'll try by all means to give you some lessons that we've did so that everyone can try to catch up. So you can catch up with us. Find the coordinates of the stationary points on the curve y is equal to. This is a curve that we are given. So you are taught to find the coordinates of the stationary points. How then do you get to find coordinates of the stationary points? For you to find the coordinates of the stationary points, what you need to do, I will say solutions. You need to get the what? You need to get the equation. So get this same equation that is given. That is y is equal to 2x cubed minus 3x squared minus 12x plus what? Plus 4. This is the curve that is given. You differentiate. So you need to do what? You need to differentiate. You say dy dx is equal to. How do we differentiate? We multiply power times coefficient. So you just say 3 times 2. That is 6. So 6x. From the power remove 1. That one becomes 2. Minus 2 times 3, that is 6x. Then this 2 minus 1, there you put a 1. You say minus the derivative of 12x, it is just 12 here. Under differentiation, we don't differentiate constant numbers. The derivative of a constant number is just a 0. So even if I don't put plus 0 here, nothing will be affected. So I say the answer is what? This is the answer, isn't it? So since I'm taught to find the coordinates of the stationary points, what I need to do, I need to get this equation equate to 0 so that I find the values of x. So I just get this particular equation. I say that is what? 6x squared minus 6x minus 12 equal to 0. Since the what? The gradient is not given. So I'll say if gradient is not given, if what? If gradient is not given. So if gradient is not given. So if the gradient is not given, then dy dx is equal to what? Equal to 0. That is the 0 that I've put there. But if the gradient was given, I would have just gone direct. So if the gradient was given, I would have said, if the gradient is 2, I would have said equal to 2. But since the gradient is not given, so dy dx is equal to 0. This part I've put a 0 there. I can reduce this. 6 is, I can reduce this. I divide both sides by 6, 6 throughout by 6 like this. So 6 there, I would remain with x squared minus 6 into 6. Once I would remain with x minus 6 into 12. That is a 2. Then I say equal to what? Equal to 0. I want you to follow me clearly here. I want you to follow me clearly and attentively. This is how you are supposed to be answering questions. This one is a quadratic what? Quadratic equation. I guess you know how to solve a quadratic equation. You can use any method that you are comfortable with. So you use a method that you are comfortable with, where you say, okay, I'll go with product, sum and factors. Product here, -2. What is the sum there? Sum is -1. What are the factors now? What are the factors? Two numbers that you can multiply to get -2. If you add them, you get -1. What are those numbers? So we get negative what? -2 and 1. When you multiply this, -2 times 1, you get -2. When you add, you are going to get -1. So these ones are the what? These ones are the factors. Since the coefficient of x squared there is 1, what I need to do now, I'll just go direct. This is x minus 2, x plus 1, which is equal to what? Equal to 0. So those of you that are facing challenges, I'm doing this because I'm teaching, but I guess we all know how to go about this. How to solve quadratic equations. Use any method. Some of you know the formula method where you say -b plus or minus. That's a formula that you know. So what we need to do here, according to this, I'll say x now minus 2 is equal to 0, or x plus 1 is equal to what? 0. I solve these two equations. I guess this is not disturbing anyone. So what I need to do, this is x is equal to 0. This is negative. When it goes this side, it becomes plus 2. So this is x is equal to 2. I say, oh, this is x. This is 0. Have you seen 0? This is positive. When it goes this side, it becomes minus 1. So meaning x is equal to what? X is equal to -1. Once you find these two values, x and y, then you've just made your life very simple. Because what you are going to do is that you are going to go back to this equation. So you are going to go back to this equation that is here. So we go back to this particular equation. I go back to this equation that is here. So this is the main equation, not the one that you had differentiated. So we've said x is 2. So you say when x is 2, have you seen when what? When x is equal to 2, what is the value for y? You say y is equal to, where there is x there, you shall put a 2. So you say 2, open bracket, x2. So 2 to the power 3 minus 3, then 2 to the power 2 minus 12 times 2, then plus what? Plus 4. You get your calculator. What you are going to do now is this. This is what you are going to do. So you punch what is there. You say 2, open bracket, 2 close, to the power what? To the power 3. So you say power. This is the power that is here. I guess you are able to see this thing here. Have you seen this one that is like this? That is the power. So I say power what? Power 3 minus 2, open bracket, 2, close, power 2, I put power 2 now, power 2 minus 12, open bracket, 2, close, plus 4. What answer am I getting? I'm getting 16. Negative 16. This is the answer I'm getting myself. So you can confirm with me. So meaning that y is equal to what? Negative 16. What is the coordinate? 2 comma what? 2 comma 16, negative 16. So these are the coordinates of the point. So I found one. I find another one where x is what? Negative 1. X is negative 1. So what I'm going to do is that I'll say when x is what? When x is equal to negative 1. So what I'm going to do now is that I'm going to say y is equal to original equation where there is x, I put negative 1. 2 negative 1 cubed minus 3 negative 1 squared minus 12 negative 1 plus what? Plus 4. So I say y is equal to, what is the answer there? So I check, okay, what is the answer? You get your calculator nicely. Don't make mistakes here. So what you do, 2, open bracket, negative 1. I can also make a mistake, so kindly follow me closely. I say power 3 minus 3, open bracket, negative 1, across, I put a square there. Then I say, okay, where am I? Squared. Minus 12, open brackets, negative 1, cross. So cross plus 4. What is the answer? The answer is 11. I'm getting 11. So here I put 11. So I know that x was negative 1. Y, it is 11. So I just conclude and say, after finding all these answers, I'll conclude and say, therefore, the coordinates, so the coordinates of the stationary points, the coordinates of the stationary points are, you write in full are, I'm going to say are what? I've got 2, negative 16, and what? And I've got negative 1, 11. These are the coordinates of the stationary points. I'm done. This is what I'm supposed to do. Just like this. I don't know if you followed me closely. This is quite involving, but when you follow me, you are able to understand. I know here now we've got the algebra that is coming in. That's why it is very important for you to know how to simplify, how to solve simple equations. So let us look at this other question. You see how questions can also come in other ways. So you can have a question that can come like this. So let me show you how a question can also come. So they get to come in so many ways. And I've told you that if the gradient is not given, then you just equate to 0. But if the gradient is given, you equate to the gradient that is given. So get that one. You've got a question like this. The equation, so the equation of the what? Equation of a curve. So equation of the curve is y is equal to x cubed minus 3 over 2x squared. That is what you are given. Then the first question you are told to say, so here then saying find. Saying find the what? Find the coordinates. So you are told to find the what? Find the coordinates. Find the coordinates of the what? Of the stationary points. Find the coordinates of the stationary. Find the coordinates of the stationary what? Stationary points. This is what we want to do. How can you now find the coordinates of the stationary points? So this is example 2, isn't it? Question number 2. A question is like this. I told you to say that the first step is where you differentiate the what? The curve that is given or that equation. This is the first thing you need to do. You say y is equal to x cubed minus 3 over 2x squared. You differentiate this. You say dy dx is equal to what? So this is equal to what? The coefficient there is 1. 3 times 1, it is 3. Then I say x. The power 3 there, we say minus 1. I'm going to remain with a 2. Minus. Here, what is happening is that this 2, when it comes down, gets to be multiplied with 3 over 2. I just want you to show you this. This 2 and that 2 cancel out. I'll just remain with a 3 there. Have you seen? Then I'm going to have x there. 2 minus 1, it is 1. So nothing will change. I just leave it like that. 1, we don't indicate. But if you want, you can show it like this. So have you seen? This is what we've done, and we've differentiated. This is the answer we get. Since the gradient is not given, I get this one. That is the 3x squared minus 3x. I equate to what? I equate to 0. But in certain questions where they tell you to say gradient is 4, you equate to the same 4 that is given. So that's what we get to do. I don't want you to be making mistakes there. So I get this part now. Have you seen? Then I say, okay, I'm going to get this and solve. So this part now is not falling under calculus. It is falling under equations, how to solve. But under calculus, so don't say, sir, I was not there when you were starting these things. No, these are equations now. So you solve this. Which method are we going to use here? Well, let's factorize. So what is common is 3x. Have you seen? Open bracket. 3 into 3, it is 1. X into x squared, it is x. Minus 3 into 3, 1. X into x, 1. So there it is just a 1. Then I equate to what? I equate to 0. So 3x, open bracket, x minus 1 is equal to 0. I get this 3x, I equate to 0. I say, oh, x minus 1, I equate to what? I equate to a 0. It is at this point now I say over 3 over 3, so that I have the value of x. X is equal to what? 0. Or x is equal to, I'm going to have x which will be equal to 0. This is negative 1. When it goes this side, it becomes positive 1. So I've got these answers, which is 0 plus 1, it is 1. So x is equal to 1, x is equal to 0. I've solved the equation. After solving the equation, I want you to get this. After solving the equation, now you go back to the original equation now, where you are going to find the values of x, using the values of y, using this one and that one. So we go now. We go to this now. I get the original equation. Y is equal to x cubed minus 3 over 2 x squared. Where there is x, I will say when x is equal to 0. Where there is x there, I shall put a 0. So y is equal to 0 cubed minus 3 over 2 0 squared. What is the answer here? It is just a 0. You are going to get a 0. So meaning that the first point is what? X is 0, even y is given as 0. So the first point is 0, 0. You say now when what? When x is what? 1. When x is 1, what is the answer? When x is 1. So you say y is equal to 1 cubed minus 3 over 2 multiplied by 1 squared. What is the answer? You don't even need to panic. Such questions will come in mathematics paper 2. So such questions will always come in mathematics paper 2, where we are going to get our calculator. 1 squared, I know that it is 1. Minus, this is going. 1 squared, it's 1. Multiplied by this, I'll just get that. So say 1 minus 3 over, it is that thing, over 2. What is the answer? I'm getting negative 1 over 2. So negative 1 over 2 is the answer. Where I'm going to say the answer is what? Negative 1 over 2. This is y. So what is the coordinate? Second coordinate, x is 1, y is negative 1 over 2. So have you seen these two? So where I'm going to conclude and say, therefore, so I'll say, therefore, so therefore the coordinates, therefore the coordinates, so therefore the coordinates of the points, so therefore the coordinates, it can be the coordinates of the points or coordinates of the stationary points. It is just one and the same. So coordinates of the stationary what? Stationary points. So say coordinates of the stationary points. This is what I need to do. Coordinates of that stationary points are what? So what am I going to do? Are 0, 0, I do this, and what? 1, negative 1 over 2. So these are the answers. Have you seen 0, 0 and 1, 1, negative 1 over 2. These are what we get to call coordinates of the stationary points. So when you are taught to find coordinates of the stationary points, this is what you need to do. So just to run you through what we've done, I've told you that if you want to find coordinates of the stationary points, first thing, get the equation, differentiate that equation. When you differentiate that, get that gradient function and equate to 0 if the gradient has not been mentioned or given. You equate to 0 like I did. I equated to 0. Then you solve the equation that is going to be formed by using the methods that you already know. General method, quadratic method, formula method, if it is a quadratic equation. But you need to be sensitive. Then after solving, you are going to find the value for two values. Sometimes it can be 1. As long as if it is 1, you just say if x is 0, you go back, you replace. After replacing, the key thing is finding the coordinates. I don't know if people are getting this. The key thing is finding the what? The coordinates. Once you find the coordinates, things become simple. So things won't even be that difficult once you find the coordinates. So don't say, this thing is too difficult for me, I haven't understood anything. Differentiate, solve the equation, substitute, you are done. So follow procedures. You can be answering this using the whole page, but as long as you know that, okay, I get the equation, I differentiate. After differentiating, I need to now solve that equation. After solving, I need now to replace in the original equation. After replacing now, so that I say if x is 0, I replace 0 to find the value of y, so that I have a coordinate. I go to this one, I do the same, so that I have a coordinate. Just like this, you are solving and things are becoming simple. Can we fail to do this? Sure, we can't. So I want you to surprise me. I'll give you just one question. I'll just give you one question that I want you to solve. Just one question. Do everything that you can to make sure you solve it. If it involves a quadratic equation, please research on the quadratic equation. You answer it nicely. I'm going to give you enough time so that you submit a wonderful work. So this is what I'm going to do. We end here, and I'm waiting for a positive response in the exercise we are going to do. Thank you so much.